looking at my screen? Just yes or no. Just type in the chat box and let me know, because I can't tell if you guys are looking at my screen. Are you guys looking at my screen? Let me know. Yes.
Yes.
Okay. All right. Thank you, Hema. Thank you, Angelica, Jasmine, Shuffle. Okay, so when you look at the graph, you have to make sure that you extend the graph. So I know it stops right here, but if it touches the edge of the graph, imagine that it keeps on going forever to the upper left. And then same on the right side. Imagine that it keeps on going forever to the upper right. So it will keep on going up and up and up, further and further left. And then the same with the right side. It will keep on going up and up and up, and it will keep on going to further and further right. So when it comes to domain, we have to figure out how far left and how far right does it go. So the furthest left, if this thing keeps on going to the upper left, the furthest left is going to be negative infinity, less than x, less than, and then the furthest right is going to be infinity. Okay, so this is the domain. All right, what about the range? So the range is how high and how low does the graph goes, okay? How high and how low. So the lowest point is obviously right here. That is the lowest point of the whole graph. And that would be 0. And then 0 less than, y less than. And then right here, we are going to use a equal to. We'll put a line right here because there is no open circle. If there is no open circle, we'll assume that it is a closed circle. So we'll put the equal to right here. And then how high does it go? Both ends of the graph is going to keep going higher and higher and higher, and it never stops. So it will be positive infinity. Okay, so this is how you find the domain and range. The correct answer is C. I actually have a typo. This should be a equal to. So that's the domain and range. And we'll work on that a little bit more later on today. So don't worry about it if you don't get it. We'll talk about it a little bit more. All right. So today we're gonna take some notes and make sure that you copy down what I tell you to. Okay. Or anything that you think is helpful. Make sure you write it down. Earlier today, 6th period, a lot of students they let's just say they did not take any notes and they can memorize anything. And they're getting destroyed on the homework. They are getting really stuck. So just make sure that you take some notes, and it's not too much stuff to write down. And if you take it, the homework is a piece of cake. Okay, moving on. So today we'll be talking about parent function. So we'll be talking about parent function, and let's see if you guys have seen that before. So parent functions, they are the origin of all functions. Every function comes from one of them. Okay, any functions that you see, they're all based off of all the parent functions. There are 8 of those, and we'll take a look at all 8 of them, and it's just take a look at how they work. Okay, and then some of them are opposites of each other. So technically speaking, you don't really have to learn 8. Some of them they are like opposites. So if you know one, you will know the other one. And then another good news, you have already learned 3 of them back in Algebra 1. Do you remember which 3 have you learned in Algebra 1? So the first one that you learn in Algebra 1 is a straight line that goes up. So this is called linear. You guys already learned it back in Algebra 1. So basically, if you look at an equations that looks like, something like y equals 2x, that is a linear function. So if it's a straight line, it's linear. You probably learned it back then. I think as early as middle school, you guys might have learned it. I think back then you guys learned y equals kx or something like this. So if it's a straight line, it's a linear. The second one that you learn is going to be an exponential graph. So it curves up. This is a exponential graph. It curves up. And then the last one, you guys probably learned it towards the end of Algebra 1. This is the quadratic functions. So the quadratic functions looks like a letter U, So these three, you probably learned it back then before, and now we're just going to, take a look at it, and then also some of the new graphs, some of the new functions. All right, so this is just a brief introduction. Let's go on to the next part. All right, so the first function that we are going to look at is the linear function. So I do want you guys to at least write down the name, write down the equation, write down this characteristic. How does it look like? And then domain and range. So these are all the stuff that you have to write down, and make sure you sketch the graph. So right here we have a graph of a linear function. You don't have to draw like a perfect graph on your notebook. So just sketch it really fast. I want you to put the x-axis and the y-axis, and then draw a straight line that goes through them. That is all I'm asking for. Okay, so just draw this and you're done. Okay, you don't have to make it look really pretty. All right, linear functions. The equation is f of x equals x. So this is the most fundamental, most basic function of all. Is basically just one straight line, okay? Just one straight line. And then make sure you understand if it's a straight line, it's a linear function. And then linear function, we can use them to make predictions, just like any other graph. So what are something that we can use it for? How about, like, remember the example that I used the other day? What if I have, like, say, the hours that you work, and then versus the amount of money that you make. So that would be a linear function. So if you work, if you make $10 an hour, and then you want to know after 4 hours how much money you'll be getting, you can go ahead and use the graph and make a prediction like this. Okay, so this is a linear function. It's very straightforward. It's one straight line. You can use it to make prediction. All right, now let's take a look at domain and range. You're in the wrong class. All right, go back to wherever that you're supposed to be. All right, so right here, we are looking at domain and range. So domain is your x, okay? Domain is how far left and how far right does your graph goes. When you're looking at this graph right here, make sure you extend the line so it keeps on going to the upper right. It will keep on going, it never stops, okay? Never stops. Same with the lower left right here. It will just going on and on and on and on, and it will never stop. So the furthest left of this graph is negative infinity, less than x, less than. The furthest right is going to be positive infinity, and that would be your domain. What about your range? So your range is going to be how high and how low does the graph goes. So if this part keeps on going higher and higher, and that part keeps on going lower and lower, and the range is going to be negative infinity, less than y, less than positive infinity. That would be your range. Okay, what about vertex? Vertex is the tip of the graph. If you look at this linear graph, it's one straight line, okay? One straight line, there is no vertex, okay? No vertex. So that means you have no vertex, no max, and no minimum. And that's for your linear functions. So that is the most basic functions. All right, let me go ahead and, all right, can you guys give me 1 second? I think I need to invite another student. All right, now moving on to the next part. All right, so the next one is quadratic function. So like I say, write down the name and then write down the equations. F of x equals x squared. This is x squared, which means x times x. You have a number times itself. That's what x squared means. And then it looks like a U. It looks like a letter U. The domain and range, we'll talk about it in a little bit. So when you look at this graph, make sure you understand that it extends forever to the upper right and also the upper left. All right, so this quadratic function, it looks like a letter U, and it is really useful in a lot of things. Like for example, let's just say if you want to calculate, if you want to throw a football, you want to see how far is it going to go. Let's just say you want to throw a football like this. You want to see how far that's going to go, and you want to know exactly where is it going to land. If you know the equation, and you know where you start, you can pretty much make a prediction and you can calculate how far is it that you're going to land. I think those people who does like a dirt bike, when they're trying to jump over some obstacles, for stunts and stuff, they have to do a lot of math too. And guess what? This is the math that they have to do. They gotta make sure that they don't over jump or they don't under jump, so they don't land on the obstacle. So these are the knowledge that they need. They need to know about quadratic functions. And it looks like a letter U. Sometimes it's an upside down U, but it will always look like a U. And then the domain and range. So domain is going to be your x's. So domain is your x's. So that means how far left and how far right it's going to go. So if you look at the left side, it keeps on going to the upper left. It will never stop. It's just going to keep going to the upper left forever. All right. So that means the furthest left that it's going to go is negative infinity, and then less than x, less than. On the right side, it will keep going to the right, to the right, to the right. It will never stop. So that means it is a positive infinity. That's your domain. What about range? Range is how high and how low that is going to go. So we will look at how high and how low. The lowest point of this graph is going to be right here. This is the lowest point of the graph. And at that point, the lowest point is going to be 0. All right, and then less than right here, if you don't see an open circle, we'll assume that to be a closed circle. So we'll have equal to, because there's no open circle, we'll assume that to be closed circle, and we'll assume the 0 is included. We'll use a equal to. So less than or equal to y, and then less than how high does the graph goes. So both sides is going to keep going up and up and up and up, and it will never stop. So it's going to be positive infinity. All right. And then is there any vertex? Is there any vertex? Vertex is, once again, the tip, right? The tip of the graph. And yes, there is a vertex right here. This is the vertex. So yes, there's a vertex. It is a minimum because it's pointed down. And the vertex is located at the origin, 0, 0. So 0, 0 is where the vertex at. All right, so that sums up for the quadratic functions. And hopefully this refresh your memory, because you should have learned it in Algebra 1 before. And this time around, we're just doing it again. And So if you know this stuff already, that's good. And if you don't know that, if you forget about it, right now is the time to pay attention. Okay, moving on. So the next function that we're going to look at is cubic function. Oh, how do you know if it's a max or a min? All right, good question, Hammer. You can know it's a max if it points up. If something points up, if it looks like this, or if it looks like that, that is a max. And for minimum would be something that points down. If you see a U that looks like this, or if you see it look like that, then that would be a minimum. So it depends on if it's pointing up or pointing down. All right, thank you for asking the clarifying questions. All right, let's keep going. So cubic function, make sure you write down the word cubic and then just quickly sketch a graph, okay? Make sure, you don't really have to make it look pretty. That is good, that is perfect, okay? Just really quickly sketch the graph. You don't have to make it look pretty. So cubic function, the equation is f of x equals x cubed. So this is x cubed, and that's how you say it. Some people is going to tell me this is x3, and no, if you say this is x3, you sound pretty, it's just not very good, okay? You don't really sound smart if you call it x3. So make sure you say it professionally, and this is x cubed, which is equivalent to x times itself times itself. So x times x times x is going to be the x cubed function. And then it looks like a letter S, sideways letter S. So if it looks like a sideways letter S, it doesn't matter if it goes like this way or if it goes like that way. If it looks like a curvy line like that, like an S, then that's your cubic function. All right, and then let's look at the domain and the range. So domain, once again, is your x, how far left and how far right. So right here, use your imagination, extend the line forever to the upper right, and then down here, extend it to the lower left. So let's see how far left is going to go. So this thing keeps going left, 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 and it will go to negative infinity, less than x, less than, and then how far right is going to go? It's going to keep going to the right forever, okay? So positive infinity. So at this point, it should be pretty easy for you guys to tell what's domain range. And if you're still struggling, that's fine. Just look at more examples. Eventually, I'm pretty sure you'll get it. All right, the range, how high and how low is this thing going to go? So the highest is going to be infinity, and then the lowest is going to be negative infinity. And then you put a y in between, okay? So your domain and your range is going to be the same, thank God. And then is there any vertex? So this graph, is there any tip? Is there any tip? And the answer is nope. There's no tip, no maximum, no minimum. Okay, so that would be the cubic function. That would be the cubic function. Hopefully you guys are not lost so far. All right, let's look at this one more absolute value function. So absolute value function, it looks like a letter V, okay? Looks like a letter V. The equation is f of x equals, these two lines is the absolute value symbol. So when you see two straight lines right here and right here, and they are around whatever numbers or letters inside, this is the absolute value symbol. So what it means is that anything or any numbers inside must stay positive. Okay, whatever's inside, it must stay positive. So right here, if you put it around the x, whatever number x is, it has to stay positive. And that's what the absolute value symbol means, okay? So when you put an absolute value symbol, these two lines around something, everything inside, it must be positive. All right, it looks like a letter V. Looks like a letter V. And I want you guys to take a good look at the graph right here. So the graph right here, it looks like a letter V. So it goes up like this, and then it keeps on going to the upper right, okay? It keeps on going to the upper right, and it never stops. Same for this. It will keep on going and going and going, and it will never stop. And what I mean by is always stay positive is, do you see there is nothing down here? There's nothing down here. Everything has to be positive when it comes to how high and how low it's going to go, okay? Let me repeat that. So when you look at the y values, how high and how low is it going to go? It will always stop at 0. It's not going to go to the negative side. Everything must be positive in terms of the vertical position. It will be 0 and up, okay? It will be 0 and up. You will not have anything down here, nothing down here, okay? Nothing. And that's your absolute value function. All right, so let's look at the domain and the range. So if you goes on forever to this side upper left, and then forever to the upper right, your furthest left is going to be negative infinity, less than x, less than positive infinity. And then the range, how high and how low is it going to go? It will go as low as this point right here. So this is a solid line, okay? Solid line, it's not an open circle. It will go as low as this. This is the lowest point. And how high exactly is it? It is 0. And then if there's no open circle, we will assume it to be a closed circle. We will put a equal to. And then y less than, how high is it going to go? It will keep on going up and up and up and up. Same with this side. So it will goes on forever to positive infinity. All right, so is there any vertex? Do you see a tip? So yeah, this is a tip right here. So this is your vertex. And this vertex is pointing down. If it is pointing down, that means you have a minimum. And then the location of the vertex is going to be 0, 0 at the origin, okay? At this point, this is 0, 0 at the origin. All right, so absolute value is also very useful because there are a lot of things in nature that is never going to be negative. So what are some things that can be negative? So things that can be negative, that would be like your bank account. If you are owing someone money, it will be negative, right? Your bank account. What about temperature? Temperature, how hot and how cold something that is, you will also hit the negative. There is negative when it comes to temperature, when it gets too cold. But what are some things that cannot be negative? What are some things that cannot be negative? So for example, weight. Can you be negative 100 pounds? Not really, right? You can't be negative 100 pounds. What about height? Can you be a negative 5 feet tall? Nope. How about volume? Volume, how much space something occupy, it will not be negative, because if you at 0, that thing doesn't exist anymore. Any lower than that, if you have a negative number, it just doesn't make sense. So absolute value is for anything that has to stay positive at all times, okay? All right, so that's everything about absolute value. So the most important part is it cannot be negative, no negatives, okay? All right, so let's, enough talking. I know probably a lot of you guys are falling asleep, so let's check your understanding. So I want you guys to match the functions with the correct statement. So there are these 4 functions that we talked about earlier, and then right here you have a description, very simple description. So use your notes to help you, and I want you to connect them. So for example, if you think linear, looks like a letter V, just connect the line like that. If you think cubic looks like a U, connect it like that, okay? So just connect the lines and match them. So go ahead and switch to peer deck. I will give you guys maybe 2 minutes to figure this out. So go ahead and switch to peer deck and see if you can figure it out. I'll give you guys 2 minutes. So if you have not been taking notes, if you have not been following along, this is going to be a nightmare for you. All right, let me see. Blue star, you're good. And then blue smiley face with a tree. Pay attention at the cubic and the absolute value. So blue smiley face with a tree, pay attention at cubic and absolute value. And then turquoise heart. I think you got it. Turquoise heart, you got it. And then yellow smiley face. You got it? And then okay, green smiley face, you draw 2 of them. That looks pretty good. And then another purple star. Okay, that's good. Purple face with sunglasses or like a visor. I think you're good. And then green face with the tongue out. I think you're good. And then smiley's face with the eyes being the money symbol. Okay, looking good, looking good. And then the heart with a lot of green dots. I think you're good. Purple smiley face, you're good. Yellow smiley face, you're good. Blue triangle, blue triangle. Blue triangle, look at cubic and quadratic again. Which one looks like a U and which one looks like an S? And then the black question mark, you are good. You just have to finish the linear and then you're done. Okay. And then one of you guys draw a crown. I think you're good. You're good. Okay, most of you guys got it correct. Only maybe a couple of you guys kind of missing it, but that's fine. That's fine. So all right, that's not too bad. All right, now go back to Microsoft Teams meeting. Go back to the Microsoft Teams meeting, and let's look at the answer. Okay, look at the answer. Go back to Microsoft Teams meeting. Forget about Peer Deck for now. So linear is straight line. Okay, so one way that I try to remember that is linear with an L. So when you're trying to spell out linear, don't you think the L is a straight line? So this is kind of how I remember it. So if you see an L, this is one straight line. So that would be your linear function. And straight line for linear. So that means you will match it up with that, right? And then cubic. Cubic looks like the letter S. So that one goes right here. Absolute value. So absolute value, you see the V, so that means it looks like a letter V. It looks like a letter V. And then the last one, quadratic. So quadratic, I want you to pay attention. And how about the U? The U right here tells you that the graph looks like a letter U. So that is how I memorize it from back then. Okay, so that's your quadratic. So that means it looks like a letter U. All right. Natalie, is everything okay? Or is someone messing around? Hey guys, I need you guys to stop being childish. If you don't want to listen to this, get out of this class. Do you understand? Stop messing each other around. So right here, you're going to learn something, you're going to pass the class, and you're going to go on with your life, and you'll be successful if you learn this. If you don't want to learn, don't mess with each other. Get out of this class. All right, now let's keep going. So right here, this is the square root function. Someone also call it radical. Okay, someone also call it radical. So these two names are interchangeable. Make sure you understand they are the exact same thing. Okay, sometimes I'll call it square root. Sometimes I'll call it square radical. And then the equation is f of x equals square root of x. And this is the square root symbol. Square root symbol. So whatever's in the symbol needs to be square rooted. You need to take the square root of whatever's inside. And then it looks like a sideways letter U, but only with the top half. So this graph is the opposite of quadratic. It's the opposite of quadratic. So let's take a look at how is it opposite. So the quadratic function we learned earlier looks like a letter U. But what if we have to push it down? Let's just say we push it over. We push it over sideways like this. So we're going to knock it to the side. We're going to knock it to the side, and then you will end up having something that looks like this. You knock the U over to the side, and you will see a sideways U, but we only want the top half. We don't want the bottom half. So get rid of the bottom half, and that would be your square rooted function. So square root function is the quadratic function, but you knock it over, you will have the sideways letter U, but only with the top half. Okay, so right here, let's try to figure out the domain and the range. So how far left and how far right does it go? So it goes as far left at this point, right? And at this point, it is going to be 0. And then less than or equal to, we have the equal to part because it's a closed circle. If we don't see an open circle, we'll assume that to be a closed circle. And then x less than, and then how far right that is going to go. So know that it will goes on forever to the right. So you will have a positive infinity. So it will go as far left as 0. It stops right here. And it will go as far right as positive infinity. What about your range? How high and how low does this thing go? So the highest point, if you look at this thing is going to keep going up and up and up to the upper right, okay? It will keep going to the right and it will also keep going up. So the highest point is positive infinity. The lowest point right here, the lowest point is going to be 0. So that would be the range of a radical function. Is there any vertex? Do you see a tip? Do you see a tip anywhere on the graph? And nope, no vertex, no maximum, no minimum. Okay, so I hope you guys are still writing down the notes, because with the notes, the homework is so easy. But if you don't write down the notes, you're not going to be able to do it at all. So the notes, I'm basically asking you these, okay? I'm asking you the domain, the range. All you got to do is copy and paste. All right, so that's it for the square root function. Moving on, we have the reciprocal function. The reciprocal functions now is going to get a little technical. So the equation is f of x equals 1 divided by x. You're falling asleep? Oh, that's not good. Go ahead and slap yourself a couple of times. And if you're not awake by then, I don't know what to do, okay? Just, try your best. We're almost done anyway. We have 2 more after this, and then you guys are done. So today is actually going to be a short day. All right, so f of x is 1 over x. So 1 divided by x, that would be your reciprocal function. And then the special thing about it is this is the only function with 2 parts. The only function that splits into 2 parts. So if you see something that splits into the upper right part right here, and then also the lower left part right here, that would be the reciprocal functions. If you see something that is split into 2, that is the reciprocal function. All right, and then let's figure out the domain. This is a little tricky, okay? A little tricky. So when you look at this thing right here, it keeps on going to the left forever, but it will never touch the x-axis. The x-axis is right here. It will get closer and closer and closer to the x-axis, but it will never touch. Same thing right here. It will get closer to the y-axis. It will get closer and closer and closer and closer, but it will never touch the y-axis. Okay, so this is a little bit tricky to understand. I mean, when you look at the line, it seems like it will eventually cross the axis, but no, actually it will never cross the axis. It will get really, really close. It will get closer and closer and closer. But if you zoom in this part, if you zoom in, it will just going to get closer and closer and closer, and then it will just flattens out. It will flattens out, and it will never touch the axis. All right. So with that said, so let's look at the domain and range. So it will go as far left as negative infinity. It will goes on forever to the left, so it will go as far left to negative infinity. Less than x, less than, right here, it will goes on forever to the right. You have positive infinity. But here's one problem. If this part never touched the y-axis, and if that part never touched the axis as well, you will have one extra statement. The extra statement is x will never equals to 0. X will never equals to 0 because this side right here, it will get closer and closer and closer, but it will never touch the y-axis. Same for this. What about the range? The range is going to go as low as -infinity, less than y, less than, it will go as high as +infinity. But then again, we will have to put y will never equals to 0 because right here and right here, they will not ever touch the y-axis. It will get closer and closer and closer and closer, but it will never touch the y-axis. All right, is there any vertex? Nope. And then asymptote. Asymptote basically means whenever a line, whenever the graph is approaching a line, but it never touched that line. So for example, you're going closer to 0, closer to 0, closer to 0, but it will never touch the axis right here. It was just going to get closer and closer and closer, but it will not ever touch the axis. That would be the asymptote. So the asymptote is the line that you will approach, the line that will approach but never reach. Okay, you get to the x-axis very close, but it will never touch the x-axis. So that is the asymptote. So you have one asymptote that is right here as the y-axis, and then you have one asymptote that is on the x-axis. So those are the two asymptotes. So y-axis, the equation is x equals 0, and then the x-axis, the equation is y equals 0. So both of these, they are your asymptote. Okay, so moving on to the next part. All right, so the next one is going to be an exponential function. All right, exponential function. So for the exponential function, the equation right here, I put it wrong, so don't worry about it. The actual equation is x a to the power of x, like this. A to the power of x. And then the characteristic is it curves up. It curves up. So it will go up like this, and it will keep going to the upper right forever. It will never stop. And then down here, it will keep on going closer and closer and closer to 0, but it will never be 0. Okay, just like before. So let's talk about the domain and range. So the domain, how far left is it going to go? It will go as far left as, at this point, hopefully you guys can get it in a snap of the fingers. -infinity, less than x, less than, and then it will keep going to the right forever. So you'll have +infinity. Okay, so that's your domain. What about the range? How high and how low this thing is going to go? Obviously, it will go as high as +infinity, but then right here, down here, it will approach the x-axis, but it will never touch the x-axis. So this is how we're going to do it. 0, less than y, less than infinity. Okay, so we don't have to put the equal to because it will never hit the 0. Okay, it will never touch the axis. And that would be the range. And then is there a vertex? Do you see a tip? And the answer is no, there's no tip. And then where are the asymptotes, if there is any? So the asymptote for this graph is going to be the x-axis because it will get closer and closer and closer to the x-axis, but it will never touch. So x-axis, y equals 0. That's the equation for the line. So you do have one asymptote. So exponential graph is very useful. So you can use it to model a lot of data. So for example, if you want to model population, that is definitely exponential. And you have exponential growth, you have exponential decay. So it depends on what you are trying to represent. Sometimes it points up, sometimes it points down. But yeah, exponential is something that you see a lot in nature. Okay, so that's it for exponential. I think we have one more to go. Okay, last one. Bear with me. Today, hopefully, it will be we'll be getting out of here soon. So the last one is logarithmic function. Logarithmic function. So the equation is going to be f of x equals log of the letter x. So right now, don't worry about what does log means, okay? Logarithmic, you don't have to worry about what it means, not right now. Later on, we'll explain to you what exactly is logarithmic. But for now, if you have never seen this word before, if you don't understand what that is, it's okay. So right now, don't worry about it, what it means. Just recognize how does it look like. So for the log graph, it curves to the right. It will curve to the right and then it will keep on going to the upper right like this. It will just keep on going to the upper right further and further up. So the domain of this graph is going to be how far left that is going to go. It will go as far left as 0, but it will never reach 0. So we will put less than, and then x less than positive infinity. That's your domain. And then the range, how high and how low is it going to go? So if you look at this graph right here, it will keep going lower and lower and lower. So that means it will go as low as negative infinity, less than y, less than, and then on the right part, it will keep going to the upper right, higher and higher. So you'll have positive infinity. Okay, so is there any vertex, max, or min? So the answer is no, because there's no tip anywhere. No max, no min. And then the asymptote, where is that imaginary line that the graph approaches, but it will never cross? The asymptote is going to be right here on the y-axis. The whole y-axis is your asymptote because right here, it will get closer and closer to the y-axis. It will get closer and closer and closer and closer, but it will never touch the y-axis. So the asymptote is going to be the y-axis, and the equation for the y-axis is x equals 0. So that is the asymptote for logarithmic function. All right, so that's it for all the graphs that you need to know. I know it's a lot of information that's thrown at you, but it does take a little time to learn. But the more that we talk about it, the more you get familiar with it. So right now, I'm just giving you a very general overview of how all the functions works. But we'll break it down later on in this whole year. We'll break it down one by one and then take a good look at how do they all work. All right, so let's answer some questions. Hopefully you guys are still with me. So right here, check your understanding. So I have a graph right here. The graph on the right shows the total cases of coronavirus in the world. So this is a graph that I just got this morning off of one of those websites that tracks the coronavirus. And I want to ask you, what kind of graph is it? What kind of graph is it? So this graph, it goes up like this, and you can pretty much make a prediction. You can kind of make a prediction. If it goes on and on, it will kind of goes up and curves up like this. My question is, what kind of graph is it? Is it linear? Is it quadratic? Is it logarithmic? Or is it exponential? So go ahead and go to Peer Deck, switch to Peer Deck, and then answer the questions. Go ahead and pick your best answer. Look at how the graph looks like. What are some characteristics that you can tell me? Does it look like a straight line? Does it look like a letter U? Does it look like a letter S? Does it split into two parts? Does it curve up or does it curve to the right? So look over your notes and tell me what is the answer. So far there are 14 of you guys. 15 of you guys respond. So that's pretty good. Keep going. I'll give you another 20 seconds. Come on, guys. Okay, let me see what you guys have. 21 of you guys answered. Thank you very much. So 18 of you guys think it's exponential. 2 of you guys think it's logarithmic. 1 of you guys think it is linear. All right, the correct answer is exponential. Okay, the correct answer is exponential because it curves up. If it curves up, it's exponential. It's not linear because linear is a straight line. We are not looking at a straight line. Not quadratic because it doesn't look like a U. Logarithmic, no, because it doesn't curve to the right. This is a exponential graph because it curves up. All right, so those of you guys who got it in the first try, that's very nice. Okay, and so now let's moving on. This is the last question, and then after that, you guys are good to go. So once again, check your understanding. Match the function with the correct statement. So just like before, can you guys match all the functions with their description? So go ahead and draw a line and match them up, please. If you need some help, look over your notes. Look over your notes, and your answer should be right there because you guys been taking notes, right? Your answer should be right there. So go ahead and match them up. I'll give you guys a minute. Okay, let's wrap it up. Wrap it up so that we can be done. 21 of you guys responded. Thank you. And I'm still waiting for another 7. All right, guys, wrap it up. All right, let's look at how you guys did. Okay, I mean, it was okay. It's not too bad. All right, purple smiley face, reciprocal, splits into two parts, okay? Splits into two parts. So you're gonna have to, be very careful. And then radical is a sideways letter U, okay? Radical is a sideways letter U. And then black smiley face, you're good. Turquoise smiley face with a check. Okay, that's good. That's good. And then there's this flower, this turquoise flower. Yeah, that's good. And then black broken heart. That's good. And then blue neutral face. That's good. And then green heart. Um, green heart. You have to be careful on the radical. Okay. And then also the reciprocal, radical and reciprocal. Those are a little tricky. Those are a little tricky. So gotta pay attention to those. And then pink question mark, that's good. And then turquoise neutral face is good. Yellow smiley face, that's good. Blue triangle, you're gonna have to look at your definitions again. And then blue smiley face, you're good. Pink star, you're good. And then the smiley face with a black eye and a red eye, you are good as well. And then purple smiley face with the tongue, oh, you're good, you're good. All right, come on, guys. These are, pretty straightforward. All you gotta do is look over your notes and then, just look at the notes and then you'll be done. It's very not challenging at all. Okay. Okay, so that's it for today. Let me show you where your homework is at. So, make sure you stay in Microsoft Teams meeting and looking at my screen. So when you go to the hub, after you go to the hub, you go to course, and then you go to your Algebra 2 class. And then all right, after you are in the class, you will go to plans. Go to plans, and then you will go to, why is it not working? Okay, go to plans and then go to full plans. You will go to down here, parent function. So don't worry about this one, okay? Don't worry about this. Go to parent function. And then you will download it right here. Okay, when you click this, you download it right here. After you finish downloading, you will finish it on your laptop and then upload it to the hub. So once again, don't send it to my email. Do not send it to my email. Upload it to the hub. So when you're done, click answer assignment and then scroll down, add files, and then pick files. So you will go ahead and find your homework, your finished homework, and then click open. And then after that, click the green submit button. Okay, so if you've been taking notes the entire class, this homework will be the easiest out of everything. But if you have not been taking notes, I would suggest you go ahead and text your friend and see if they can, share the notes with you. Take a picture, send it to your phone, something like that. And one more thing, today you guys will have a homework due later on tonight. Later on tonight at 11:59, that is the due date for your domain and range homework. So make sure you submit it on time. If you have not finished, make sure you finish it. And then yes, and today's homework is going to be due on Friday, so you guys have the time. So make sure you finish last week's homework So other than that, that's it for today. Thank you for participating, and some of you guys, I know today is a little bit too much information throwing at you, but I'm pretty sure you guys can handle it. So you guys are dismissed. I'll see you guys again on Thursday. Okay. All right. See you later, Hammer. See you later, Jasmine. Natalie, yes, I'm doing the attendance right now. So if you've been here, you're good. Okay. If you've been here, you'll be all right. So don't worry about it. Yep, that's it for today. If you want to stay and finish the homework right now and turn it in right now, you can do it. You can just stick around. Yeah, see you later, Ricardo. See you later, Shuffle. All right, see you later, Francisca. So if you want to stick a little bit longer and if you need my help on the homework, you can stay. But other than that, you guys are dismissed. You guys can go ahead and take a little break and make sure you go to 8th period on time, okay? 8th period start at 1:55. So, yep, that's it. You all have a good one. See you later, Marianne.